Hello, this is 6.2, number 4, 13 from the book. This is 4b, or we're going to try to solve differential equation. So they give us dy dx equals x times 9 minus y, and the initial condition of 0 for x corresponds to negative 4 for y. So it says find the particular solution of the differential equation. So here we go. First I'll go ahead and bring that dx over. And we'd have essentially like a dy equals x times 9 minus y dx. And if we divide both sides by 9 minus y, we'd have 1 over 9 minus y dy equals x dx. And if we integrate both sides, integral of 1 over 9 minus y dy equals the integral of x dx. What we have is natural log of the absolute value of 9 minus y divided by negative 1, y divided by negative 1 because the derivative of y would be negative 1, and so we need to bring that in there, equals x squared over 2 plus, I'm going to call it c1. And I'll give this negative to the other side, so we'll call this natural log of the absolute value of 9 minus y equals negative x squared over 2. Plus c1, and the negative could be absorbed or not absorbed into c1, it doesn't really matter. So now I'm going to say e to the natural log of the absolute value of 9 minus y is e to the negative x squared over 2 plus c1. And that has the effect that the e and natural log essentially cancel out, and we have a 9 minus y equals e to the negative x squared over 2 e to the c1. Now, because this has a sum between these two powers, you can write it as e to the first one and then e to the next one. And that has the effect that this c1 can now become a c2. E to the c1 is c2. So, take this to the next step. Subtracting 9 from both sides, what do we have? Negative y equals negative 9 plus c2 e to the negative x squared over 2. And we could divide the negative 1 into everything. Y equals 9 minus c2 e to the negative x squared over 2. And yes, we could have had that c2 absorb the negative. Now we have that initial condition of 0, negative 4. So we'll plug this in. Y of 0 equals 9 minus c2 e to the negative 0 squared over 2. And that's going to be negative 4. So that means we're going to have 9 minus c2. Well, e to the 0 is just 1. c2 times 1 is negative 4. And we can subtract 9 from both sides so that negative c2 equals negative 13, meaning c2 equals 13. And if we bring this back into our original equation, y equals 9 minus 13 e to the negative x squared over 2. And that is the solution to the initial condition with our particular solution. Hope that helps. Thanks.